Okay, so logarithms, which we generally call logs, they are to do with the indices of a number. So we use them to solve equations where the index is unknown. So what you need to think about is things like when we talk about compound interest and we say to you, how many years do you need to invest $10,000 for at whatever rate of interest to earn this much interest? Logs can be used to work out what the power is, where before we've needed to do guess and check. Okay, so definition of a log is given to you here in red. So if a to the power of x is equal to y, then log of ay is equal to x. Now, it sounds really confusing, but what I need you to remember is the terminology. So a is your base. Okay, x is your power, and y is your answer. Okay, base, power, answer, none of those things are new, but the way that we relate them to log is, you remember, BAP, because it goes base, answer, power, and that tells you what number to put where in your log. Okay, so have a look at some examples that we've got down here. We know that 2 to the power of 3 is equal to 8. So if they want to know what log base 2 of 8 is, well, as we just said, how do we do it? Well, we say that this is the base, this is the answer, and we're trying to find the power. So 2 to what power is equal to 8? Well, we know that that's a 3. All right. So log base 3 of 9. Well, your base is 3, your answer is 9, your power, because we know that 3 squared is equal to 9, the power is 2. Well, we know that 5 cubed is 125, so log base 5 of 125 is equal to 3, because it's 5 to the power of 3. Now that all seems really simplistic, and that's generally not the way your questions are going to work, but you have to be able to transfer from something written as an index to something written as a log and back again. Okay, so let's do it in reverse. We've got log base 2 of 128, and we want to know what that's equal to. So again, go back to that BAP, B-A, we're trying to work out the power. So what this means is that 2 to some base number is equal, 2 to a power is equal to 128. Any ideas? Your power is 7. If you're not sure, just use your calculator and work it out, but it's 2 to the power of 7 is equal to 128. Let's have a look at the next one. So again, log base 3 of 127. So 3 is your base, 1 over 27 is your answer. We're trying to work out what power that would be. So let's see, what does that mean? So 3 to some power is equal to 1 over 27. Well, the fact that it's gone from this whole number 3 to a fraction tells me that x needs to be negative. And what do we have to raise 3 to get the answer of 27? Well, 3 squared is 9, 3 cubed is 27. So the answer to this is negative 3. Okay, so on our calculator, we can evaluate logs that don't work out nicely, like log base 2 of 8. We know that 2 to the power of 3 is equal to 8, but we can use logs to evaluate ones that aren't nice, easy whole numbers. Okay, so on your calculator, you have 2 buttons. You have this one here that says log, L-O-G. That is log of base 10, which is easy to remember because it has the 10 written above it. It's nice how they did that. We've also got this one here, Ln. This is log base E, which has the E written above it. And that is called a natural log. So Ln because it's the natural log. Okay. Now both of these can be very effective for problem solving, and you will have the opportunity to use both of them. But for the moment, we're just looking at how to use them. So Our first question asks us to evaluate log base 10 of 7.2. So what this means is 10 to what power is going to equal 7.2. That's not one that we can do easily. We don't have any indices rules that will allow us to simply solve that. So we use our calculator. Log. So if it's log G, that's your base 10, so it already takes care of the 10. 7.2 equals, and there's my answer. So to evaluate this, I get 0.857332494. Please remember, write your whole calculator answer before you round off, because there is only one question in your whole paper where they will care about that, and if you write the whole calculator answer every other time, you will never lose a mark for rounding incorrectly. But if you don't write down your whole calculator answer and you round off incorrectly, you can lose marks. So get into that habit. So if I round that off to 3 decimal places, I am getting 0.857. And in our second one, they want us to evaluate the natural log of 20. So that means e to what power is equal to 20. So use your natural log button, 20, and equals. So e to the power of 2.995732274 would be equal to 20. Okay, so again, whole calculator answer, 2.995732274. Now this time we are rounding off to 2 significant figures, and for some reason we all forget what that means. It means that we start counting at the first non-zero digit. So that's the first significant figure. This is the second significant figure, and that is where I am going to round off. So if I round that off to 2 significant figures, 2.9, your next number's a 9, you need to round up. That is 3.0 to 2 sig fig. You can write out significant figures if you want to, but nobody expects you to. That's what you need to do exercise 4.4. Good luck, and I will see you in class.